Okay, so hello and welcome. We are looking at simplifying expressions. So these things are critically important, and I'm going to be breaking down the examples into content that's both relevant for grade 11 as well as grade 12, and then also content that's only relevant for grade 12. Remember to have your summary sheet ready, and it's something you're going to refer back to often until such time that it becomes engraved as a neural pattern in your brain. Okay, so here's the first example. It is tan of 180 plus theta, right, multiplied by square root of 1 minus sine squared. And I'm going to do my best to color code this. Square root of 1 minus sine squared of theta. That's our parameter argument over here. All divided by cos of 90 minus theta. Okay, which I'm going to do in violet. Okay. Now, since we're dealing with an expression, we can simply go ahead and simplify this. We don't need to actually write left-hand side or right-hand side now. We can just go ahead immediately and write is equal to, right? And that's what we want to do. We want to simplify this. So let's start off tan with 180 plus theta. Firstly, we need to identify which quadrant tan 180 plus theta is in. It's in the third quadrant. And in the third quadrant, we identify that tan is going to be positive. Okay, so that's what I put in here. I just simply make this positive tan of theta, right, of the acute angle that is added to the 180. Now I've got the square root of 1 minus sine squared. I'm just going to put that on a new page. Square root of 1 minus sine squared theta is equal to the square root of, this is an identity which we are well familiar with, cos squared theta, and that's going to be just cos theta, because the square falls away. Okay, so we can conclude that the entire square root of 1 minus sine squared theta is just going to be multiplied by cos of theta. Okay, then I'm going to divide that further by cos of 90 minus theta. Now I want to point out something. When you look at 90 minus theta, right, you can clearly see that it's not 180 minus, not 180 plus, not theta, and not 360 minus theta. Rather, when we see any of these, 90 plus, 90 minus, 270 minus, 270 plus, know that this is relevant for co-ratios. Okay? It's relevant for co-ratios. So I've seen it here, and it means I need to apply co-ratios to it. There are two steps to co-ratios. Step number 1 says identify where this angle lies. So if we go back, we can clearly see that 90 minus is in the first quadrant. So this is going to be quadrant 1. Okay? Then I need to say what is cos in that quadrant. Cos is positive, so I'm going to put down the positive, and I'm going to do it in violet so as to color code that that's what I'm working with. And it's just going to be the co-ratio of cos, which is sine, and its argument is theta. Okay, and there we go. So now I'm almost done. I'm going to simplify this further. I'm going to say tan of theta, a grade 11 identity, says sine theta over cos theta multiplied by the green cos theta that we get over there, all over sine of theta, right? That's our denominator. So sine theta will remain at the bottom, and we're going to try and simplify the top now, which I can clearly see. Cos theta cancels with cos theta, and I'm left with a sine theta. So once I've simplified this very first equation, or rather expression, right, I can see sine theta divided by sine theta is equal to 1. Okay, and there we go. That's the first example that has been simplified.